In this video, we're going to learn how to identify and handle outliers. That is, data that stands out from the rest. So generally speaking, outlier detection is an unsupervised learning technique in machine learning, whose goal is to find data records and that's specifically rows of data that are very different from most of the others. There's two very different approaches or goals for which outlier detection might be applied. One is a class of problems called anomaly detection, and that's where this is the primary goal of the data mining analysis. And this tries to identify which data records are unusual. Some examples are when there are manufacturing traces, manufacturing process data, trying to find the root cause of a problem. What was unusual in the process that eventually led to a machine breakdown, for instance. Then in airport security screening, there's millions of people that pass through airports. You don't want to stop them all, but you'd like to identify who is unusual. Like perhaps you identify someone who travels a lot, it's not for business, and they have relatively light luggage, and they don't seem to have large income. Well, maybe that's someone they should screen. Perhaps they're moving drugs across the border. Then another case is for fraud or intruder detection. Perhaps you have a bank card, and then your bank detects that suddenly you bought a big screen TV and you're having it shipped in a city that is 500 kilometers from where you live. Well, that might be flagged as an unusual transaction, possibly fraudulent. So block that transaction, and someone from the bank will actually call you to really make sure that that's you. Then spam identification applies anomaly detection. You have emails that you normally receive, but which email messages are rather different from what you typically receive, and that might end up in your spam box. So this is a major class of problem. Another very different goal is in not as the primary goal of the analysis, but just in the course of cleaning data and making sure that there's no problems in data. Outlier detection might be carried out because maybe some outliers are errors. And so that's what we're going to look at here, especially uh, outlier detection for the purpose of data cleansing. So first, let's talk about unidimensional outliers, specifically numerical outliers. And again, this is from the error detection perspective. So an outlier generally is a very unusual value that is quite different from what is normally expected. There are categorical outliers, which are non-numeric, and that's when you have a very rare value, like maybe a categorical value that occurs maybe only 1% or fewer times. That might deserve scrutiny to make sure if that really is what it is. Uh, Generally, numeric outliers, which we're going to focus on more on this video, are numbers that are unusually higher or unusually lower than what is normally expected. There's always a question of how high is too high, how low is too low. Well, it really requires a human intelligence to determine that. And it's human intelligence that determines what is expected and what is beyond what is expected. Now, numerical errors are very difficult or even impossible to find if they fall within a normal range. So, for instance, if people's ages in your data set normally fall between 18 to 80, and someone is 56 years old but is accidentally typed as 65 in the data set of 1,000 people, it's going to be very hard to detect that, almost impossible. But fortunately, that kind of error within normal ranges in a large data set really does not negatively affect statistical results. It's just a rounding artifact, and it won't change results significantly as long as it doesn't occur too often. On the other hand, you can have some numbers that are way too high or way too low, and those can influence and change some models. Some models are robust to outliers, others are affected by them and will change results in significant ways because of outliers. And that can be problematic. However, the positive side of that is that outliers that really stand out are usually relatively easy to detect because they're so different from the rest. However, so far we've been talking about unidimensional outliers, those that are unusually high or low. But what is more challenging are multidimensional outliers. So let's look at this here. So here we have a little data set with two variables, and they could represent anything. Variable 1 ranges from -3 to 3. These are usual values. So usual values will be from -2.5 to up to 2.5. Then variable 2 ranges normally from -3 up to about 3. These are normal values. So here we have this data point here highlighted in red, and it is a very normal value on variable 1. It's about -1.8, which is a normal standard value. And on variable 2, it falls around 1.5, which is a normal value for variable 2. But when you combine variable 1 and 2, that particular combination seems rather unusual. And that's because the vast majority of data points falls more or less within this oval here. But here you have this variable standing out way outside the normal combination. And so it takes an examination on the two dimensions to identify something that is unusual in this sense. And now, if you are looking at things in 3 dimensions, okay, you might be able to see it. But if you have 4 variables or 5 variables, then it goes beyond the ability of human eyes to be able to detect things that are unusual only with those combinations. But computers can usually handle multiple dimensions as easily as they handle 2 or 3. So that's normally how those would be identified. So to handle or fix outliers, first look at this little data set and just pause the video for a moment and see if you can identify any outliers there. Okay, so here we have income. This income here, most incomes will range from a low of 22,000 euros per year up to a high of 91,000 euros here. But this one is 1.6 million euros per year. For family income, that's pretty high, and at least that definitely stands out relative to the others in the data set. So outliers have different causes. Like what? So the fact that this stands out makes it an outlier. Is it good? Is it bad? Real or not? Well, you have to try to figure out what's going on there to figure out how to fix it. So sometimes the outliers are errors. They're errors for the same reason as categorical errors. And so it might be just a typo. Maybe someone typed too many zeros. And that's why instead of 16,000 euros, it became 1.6 million euros. Sometimes it's a legitimate value. It just happens to be very high or low. So it could be in your data set, you do have a millionaire. Yes, it happens. And so that's where it is. And you say that's fine for a data set, that it's the true data, it's characteristics. So you just leave it there. However, sometimes even if it is a true value, it's not an error, but it's extremely rare and it's not really representative of the majority of the database. So, for example, the average income in this data set, if you exclude this millionaire here, let's assume it's a legitimate millionaire, the average income is around 64,000 euros per year for family income for people in this data set. But when you include this millionaire here, then the average income jumps to 217,000 euros per year. and you have the impression they have a very affluent customer base, whereas that's not the case. And so if you have an outlier that really skews the results for everyone, you might just delete it and you just say that your data analysis represents the vast majority of people, but it does not accurately represent this exceptional millionaire. But that's fine because they are already exceptional. What's the most appropriate thing to do? Well, there's no one answer. It requires human intelligence to determine the correct way to handle an outlier depending on the particular situation and depending on your particular goals.